we basically have 1, 2, 3, 4, and really I should put rational on here as well. Those are the 5 big categories for doing U subs. So polynomials would be like saying if I have x squared, let's say 4x squared plus 3x plus 7 times 8x plus 3 dx. That would be an example of a polynomial U sub.
What is it for?
This is just a quick review.
Oh.
Okay, so in other words, we see a function here, and we know this is the derivative because we see a reduced power, right? And that sort of stuff. Okay, so that would be a good polynomial example. A trigonometric, I always go back to this example only because I see it on a lot of tests, on a lot of AP tests. Rewriting tangent as sine over cosine. There's where that rational expression comes in. Those are always really good for U subs. In addition, here's another good U sub for trig. Something like that, where we could say U equals what? Not even that. Not even all of that. Tyler said U equals sine cubed. Not even all of that. U equals what? Sine. Yeah. U equals sine of x. Because if we let U be a sine of x, then when we take the derivative of that, what do we get? Cosine. We get to substitute out that. Okay. So if we let U be a sine of x, then our du dx is a cosine of x dx. Okay, so those are also really nice for trig subs, and then now all we're doing is integrating U cubed, much easier than trying to integrate something like that. Okay. Logarithmic and exponential, really the focus here is exponential. I have some on the homework, but really we're going to hit that in section 4. But exponential, a good U sub would be something that looks like this. E to the x squared plus x power times 2x plus 1 dx. Do you see the U sub? There's the U. If we let U be the x squared plus x, then what happens to my derivative? My derivative ends up being 2x plus 1. So instead of trying to do the antiderivative of that big thing, this boils down to the antiderivative of what? When I substitute and substitute, I end up getting the antiderivative of I'll let you think about that for a little bit while I scoot this over. I substitute, and this becomes what?
E to the U.
E to the U, and I substitute, and this becomes
Du.
du. Exactly. How many of you would rather take the antiderivative of that? Because what is the antiderivative of e to the u?
E to the U.
Right? Oh, good catch on the plus c. Right? That was one of the things we discovered, that the derivative of e to u is e to the u, and if we work backwards, then the antiderivative has got to be e to the u. Much easier than trying to take the antiderivative of that. Okay? And then a radical example would be like the fifth root of x to the fourth plus 2x cubed. How complicated does that look? But times, and I'm going to write something next. What do you think I'm going to write here?
4x to the third plus 6x squared.
Yep, exactly. Or I could have actually written 2x cubed plus 3x squared. I could have written something that was just half of it. Okay? So radicals might look like this. If I leave it like this, then this just ends up being, after I make my u subs, what's my u here? Yep, what's my du dx? So this ends up being just integrating what?
That's the root of u times du.
Yep, u to the 1/5 power du. Well, I haven't integrated it yet. Yeah. Okay, so those are really common examples. You know, just something where you see a radical and then you see its derivative or half of its derivative or twice its derivative on the outside. Okay. So questions about that? And if I wrote too fast, I can scroll back up to get other stuff if you want me to. The next page, and I'm not going to go there on the screen, but this next page, number 2, has all of the trig antiderivatives. And so I mentioned yesterday that if you want to put that in the program in your calculator, I would show you how to do that. Okay? So if you want to make that as part of your next, this day and the next couple of days, let me know. The last page is really just summarizing what we just did here. Okay, so any questions about what we just went through before I kind of change focus and talk about the schedule?